October 29th, 2003. Halloween was approaching, but something far more terrifying than any costume was hurtling toward Earth at nearly 3 million miles per hour. Most people had no idea what was coming. But deep in laboratories and control centers across the world, scientists watched their screens with growing dread. This is the story of how our modern world, built on invisible signals from space, nearly collapsed in 72 hours. A story of the sun's fury, human ingenuity, and the fragile threads connecting our technological civilization. Before we understand what nearly happened, we need to understand what we almost lost. GPS, 3 letters that have become as essential to modern life as electricity or running water. But unlike those utilities, GPS remains invisible, taken for granted, quietly working 20,000 kilometers above our heads. 31 satellites, circling our planet twice a day, each one broadcasting the same message: I am here and the time is now. Simple, elegant, revolutionary. People think GPS is just about finding the nearest coffee shop, but it's so much deeper than that. Every time you withdraw money from an ATM, GPS is timestamping that transaction. When your cell phone connects to a tower, GPS is synchronizing that network. The power grid uses GPS to coordinate electricity flow across continents. We've built our entire civilization on top of this system without really thinking about what happens if it goes away. By October 2003, the world had become completely dependent on GPS timing signals. Financial markets used them to timestamp trades down to the nanosecond. Telecommunications networks relied on them to keep millions of phone calls synchronized. Emergency services dispatched ambulances and fire trucks using GPS coordinates. And thousands of aircraft, crisscrossing the skies, trusted GPS for navigation. But there was a problem no one had fully anticipated. 93 million miles away, our sun was waking up. The sun operates on an 11-year cycle, moving from quiet periods to violent ones and back again. In 2003, we were approaching what scientists call solar maximum, the peak of the sun's activity. But no one expected what was about to happen. October 28, 2003, scientists monitoring the sun through the SOHO spacecraft noticed something unusual. A massive sunspot, later designated AR 486, had rotated into view on the sun's western limb. It was enormous, bigger than Jupiter, and it was crackling with magnetic energy. When we first saw AR 486, scientists knew they were looking at something special. The magnetic field complexity in that region was off the charts. Alerts started going out, but honestly, even the experts didn't anticipate just how violent it would become. At 11:10 UTC on October 28th, those twisted magnetic fields finally snapped. The release was cataclysmic. An X-17 class solar flare, one of the most powerful ever recorded, erupted from the sun's surface. Within minutes, a blast of X-rays and extreme ultraviolet radiation slammed into Earth's upper atmosphere. But that was just the opening act. Following the flare came something even more dangerous, a coronal mass ejection. A billion-ton bubble of superheated plasma and tangled magnetic fields blasted into space at speeds exceeding 2 million miles per hour. And it was heading directly toward Earth, at NOAA's Space Weather Prediction Center in Boulder, Colorado. The atmosphere shifted from routine monitoring to crisis management. When forecasters saw the speed and trajectory of that CME, they knew they had maybe 30 to 40 hours before impact. They immediately started making calls. Airlines, power companies, satellite operators, GPS authorities. The message was simple: something big is coming, and you need to prepare. But October 28th was only the beginning. What scientists didn't know was that the sun had more in store. Much more. October 29th, the first coronal mass ejection was still racing toward Earth when Sunspot AR-486 erupted again. Another X-class flare. Another massive ejection. Then another and another. In less than 48 hours, the sun fired off 11 major solar flares, including 2 of the most powerful in recorded history. It was as if our star had decided to empty its entire arsenal at once. Scientists call these events solar storms, but that's almost too gentle a term. This was a bombardment. Wave after wave of radiation and plasma hammering Earth's magnetic field, and each one was compressing and distorting our protective magnetic bubble in ways we'd never seen before. Earth's magnetic field, our invisible shield against solar violence, was being pummeled, and as it compressed and twisted under the assault, something critical was happening to the GPS constellation orbiting above. GPS satellites operate in medium Earth orbit, about 20,000 kilometers up. During normal conditions, they're relatively protected, but these weren't normal conditions. The solar storms were flooding this region with high-energy particles and intense radiation, and the effects were immediate. GPS operators started seeing anomalies across the constellation, signal degradation, positioning errors. Some satellites went into safe mode automatically. The precision we'd come to expect, accuracy within a few meters, was deteriorating to tens of meters, sometimes worse. For aviation over the ocean, that's a serious problem. October 29th evening. As the first major wave of solar particles hit Earth's atmosphere, the real crisis began to unfold. The aurora borealis, normally confined to polar regions, blazed across skies as far south as Texas and the Mediterranean. Beautiful, ethereal, and a sign of just how much energy was being dumped into Earth's atmosphere. At air traffic control centers across North America and Europe, controllers faced an unprecedented situation. GPS accuracy was fluctuating wildly. Aircraft on transatlantic routes, normally guided by precise GPS navigation, were reporting position uncertainties. Pilots flying over the Atlantic on October 30th started getting GPS anomalies. The system would show aircraft in one position, then jump to another location miles away. As pilots, they're trained for equipment failures, but when you're over the middle of the Atlantic with 300 passengers, and your primary navigation system is going haywire, it gets your attention. Airlines were forced to revert to older navigation methods, but the solar storms affected those too. Radio communications were disrupted. High-frequency signals, used for long-range communication with aircraft, were being absorbed and scattered by the ionized atmosphere. At sea, the situation was equally dire. Container ships, oil tankers, fishing vessels, all relying on GPS for navigation, found themselves essentially sailing blind in some regions. For modern shipping, GPS isn't optional, it's fundamental. Captains use it for positioning, for timing engine systems, for coordinating port arrivals. When it started failing during those Halloween storms, captains had to dust off skills that hadn't been used in decades. Celestial navigation, dead reckoning. It was like going back in time 30 years, except ships weren't designed for that anymore. But perhaps the most critical vulnerability was one the public never saw. In server rooms and data centers around the world, the precise timing signals from GPS satellites were becoming unreliable, and that threatened the entire financial system. Modern financial markets operate on microsecond precision. When you execute a stock trade, GPS timing determines the exact sequence of that transaction. During the Halloween storms, that timing started to drift. We're talking about microseconds, but in high-frequency trading, microseconds matter. If the timing synchronization fails across the network, the entire system can collapse into chaos. Emergency services reported GPS failures affecting dispatch systems. Ambulances took longer to find addresses. Police units had trouble locating backup. In rural areas, the impact was even more severe. And then there were the power grids. Across North America and Europe, grid operators watched nervously as GPS timing signals flickered. The synchronization of power flow across interconnected grids depends on nanosecond precision. Lose that, and cascading failures become possible. October 30th was the worst day. Multiple systems were failing simultaneously. GPS degradation, radio blackouts, satellite anomalies, and forecasters knew another major CME was still incoming. There was a real possibility they were looking at a complete breakdown of critical infrastructure. In government offices and corporate boardrooms, contingency plans were being activated, plans that had seemed theoretical just days earlier. But here's what the Halloween solar storms revealed. When pushed to the edge, human ingenuity rises to meet the challenge. Brilliant people worked around the clock. Engineers recalibrating satellite signals, operators manually commanding satellites to compensate for radiation effects. They were essentially flying blind themselves, but they kept the system alive. Barely. Airlines increased spacing between aircraft, reverting to decades-old navigation procedures. Pilots communicated position reports manually. Air traffic controllers adapted routing to avoid the worst affected regions. At sea, experienced captains taught younger crews how to use sextants and paper charts. Emergency frequencies crackled with vessels sharing position information, creating an ad hoc navigation network. What pilots remember most from those flights wasn't the fear, it was the cooperation. Controllers, pilots, dispatchers, everyone working together. When aircraft landed safely, there was this shared sense of, we made it through something serious. In laboratories worldwide, scientists worked frantically to predict the storm's evolution and provide advanced warning of each new wave. Their forecasts, rough as they were, gave operators precious hours to prepare. Researchers learned more about solar storms in those 72 hours than in the previous decade. Every observation, every data point was critical, and information was being shared globally in real time. It was science under pressure, but it worked. October 31st, Halloween night. As children across America went trick-or-treating, the final major wave from the solar bombardment swept past Earth. The storm was ending, but the implications were just beginning. When it was over, the world took stock. No GPS satellites had been permanently lost. No aircraft had crashed. No ships had sunk. The power grids had held. By some measures, we'd been lucky, but we'd also been warned. 28 satellites across multiple systems had reported anomalies. GPS accuracy had degraded by up to 90% in some regions. Communications had been disrupted. Airlines had lost millions in delays and route changes. And all of it had happened during a storm that, while severe, wasn't even the worst-case scenario scientists could imagine. The Halloween storms were a wake-up call. They showed us just how dependent we'd become on GPS and how vulnerable the system was to space weather. The question became, what do we do about it? In the years following 2003, significant changes were made. Satellites were hardened against radiation. Backup systems were implemented. Space weather forecasting improved dramatically. Protocols were developed for degraded GPS operations. The lesson was clear. Resilience isn't about making systems invulnerable. That's impossible. It's about building in redundancy, training people for worst-case scenarios, and maintaining the capability to operate when technology fails. Today, GPS is more robust than it was in 2003. Multiple satellite constellations, American GPS, European Galileo, Russian GLONASS, Chinese Beidou, provide redundancy. Ground-based augmentation systems offer backup. and we watch the sun more carefully than ever. NASA's Solar Dynamics Observatory, launched in 2010, provides real-time monitoring of solar activity. NOAA's Dioscovior satellite, orbiting
GPS.
between Earth and the Sun,
Position.
gives us early warning
Checking
of
auxiliary
incoming
navigation.
CMEs.
Hold present
We've
course.
built a defensive network in space, Bob Bar. The sun, as we learned in 2003, is unpredictable. Right now, as you watch this, the sun is moving through another activity cycle. Solar maximum is approaching again. And the question isn't if another major storm will occur, but when. Scientists have identified historical events, like the Carrington event of 1859, that were far more powerful than the Halloween storms. If something of that magnitude hit us today, even with all our improvements, we'd face catastrophic disruptions. GPS would likely fail completely for days or even weeks, bar on-sider what that means. In 2003, we had roughly 1 billion GPS receivers worldwide. Today, there are over 6 billion. Your smart phone, your car, your smartwatch, all rely on those invisible signals from space. Supply chains are synchronized by GPS timing. Autonomous vehicles navigate using GPS coordinates. 5G networks use GPS to coordinate data flow. We've doubled down on GPS dependency since 2003. We've built more of our civilization on top of it, not less. Which means the next major solar storm, when it comes, will find us more vulnerable in some ways, even if we're better prepared in others. But there's hope. A new generation of scientists and engineers, many of whom were children during the Halloween storms, are developing solutions, quantum timing devices that don't need satellites, underground fiber networks for precision timing, advanced forecasting models that could give us days of warning instead of hours. The lesson of 2003 is that we can't afford to be complacent. GPS is incredible, but it's fragile. We need alternatives, backups, and we need to remember that all our technology ultimately depends on the goodwill of a massive nuclear reactor 93 million miles away. That's humbling. The Halloween solar storms of 2003 lasted 72 hours. Most people didn't notice. Flights arrived a bit late. Ships took longer routes. But behind the scenes, we came closer to technological catastrophe than many realize. Those of us alive today live in a unique moment in human history. We're the first generation to build a global civilization dependent on signals from space. And we're learning, times the hard way, that space is not empty, quiet, or safe. The sun that gives us life also has the power to disrupt everything we've built. It's a reminder of our place in the universe, ingenious, technologically advanced, but ultimately small and vulnerable. But it's also a reminder of something else. When crisis comes, whether from the sun or elsewhere, we have something more powerful than any satellite constellation: human adaptability, cooperation, the ability to look at disaster and say, we'll find a way. October 29th through January 31st, 2003. The days the world almost lost GPS. We survived, we learned. And we're still here, looking up at the sky, navigating by stars we put there ourselves, waiting for the next time the sun reminds us who's really in charge. The question is, will we be ready?